Hello, class. This is Unit 1, Day 5 notes for volume. And I know volume is something you've probably been doing for a while. We are going to focus on some basic formulas, and the formulas that you're going to see here are ones that you're expected to memorize. So don't just rely on always looking them up. Think about them as you're writing them down. My suggestion, always write down the formula every time you use it before you plug in numbers until you get it down. So talking about volume, the basic volume that we always use is a rectangular prism or a box, which is just length times width times height. But any prism, general formula is big B times the height, and that just means base area. So it might not be a rectangle. In this case, it's length times width if it's a rectangle. But it could be a triangle, which is 1/2 base times height. It could be a circle, which is a cylinder, which is pi r squared. So that's just the base area. A cube is a rectangular prism where all the sides are the same. So we call the sides S for sides. Side times side times side. Well, guess what? That's side cube. So that's where that comes from. That's where the name comes from, actually. Fun fact. A cone is a cone has two components to it. The radius, you might be given the diameter, but cut that in half if you are. And the height, which is always going to go to the center if it's a right cone. If for some reason you're given this, which is called the slant height, you would use the Pythagorean theorem to get the height of the radius, depending on what you're given. Something that might come up is circumference. So if you're given the circumference, you need to recall that it's pi times the diameter, or you might think of it as 2 pi r. Sometimes you have to solve for r to be able to plug it into this formula. And the formula is 1/3 pi r squared times the height, or you can think about it as pi r squared times the height divided by 3. So you can put the 3 on the bottom of it all if you want to. A pyramid also has that 1/3 because it comes to the point. This just stands for the base area again. So whatever the shape, if it's a square like this picture here, it's just, length times width, but it might not be a square. It could be a triangle. So that's the base area. And the height usually goes right to the center, unless it's drawn, a little bit off, but usually it goes right to the center there. And finally, I would say probably, actually there's two more, but one of the most common ones you come across is a cylinder. And that's really just the base area. Hopefully you recognize pi r squared. That's the area of a circle. So it's just the circular base times the height. There's your radius, of course. There's your height. And the last one is a sphere, a ball, a globe, anything, circular shape, three-dimensional is considered a sphere. This formula is 4/3 pi r cubed. Make note of that cubed. Sometimes the square gets put in there accidentally for a sphere, but you want a 3 there and there, and that's a 4. Radius goes from the center to any point on the edge, so it could be there. That's also a radius. As long as it goes from the center to the edge, it's a radius no matter what. So let's work through these. There's 5 examples to work for volume. And then you'll have enough information, hopefully, to do well on your day 5 assignment. So to start with, we're talking about a cylinder. A cylinder has a height of 6 and a radius of 10. What's the volume? That's a basic plug-in in. So volume of a cylinder formula, look it up. Pi r squared h. Plug in your R and your H. You don't need parentheses to plug it in. I just usually do that out of habit. There's two ways to approach this problem. You can do it in terms of pi, or you can do it as an approximate decimal. If you do it in terms of pi, don't type pi in your calculator. Just do 10 squared times 6. That's 600. Just write the pi next to it, rearrange those so that it's 600 pi. And that's going to be cubic centimeters. If you do it as a decimal, times by pi. So 600 times the pi button is here. I'd recommend using that over 3.14. It gives you a little bit more accuracy. And you get 1884.95555. And I'm going to round that second 5 up to a 6. So I want you to understand that these are the same value. These represent the same thing. This is just in terms of pi. So that's exact. And this is approximate. And not one is better than the other. It's just sometimes they're represented in different ways. So I'm going to circle them both. And if it doesn't specify, you can do either one. But a lot of times on a test, on a multiple choice test, you often find that these are in terms of pi. So it's very helpful to know that you're not typing pi in the calculator. Okay, next example. A conical cup, that's cone, is 15 centimeters long. Now hold up there. That's not the height. We'll talk about that in a minute. Radius is 4. Question wants to know how many liters of water will hold the cup. Will the cup hold? Now it's given to you in centimeters. They do give you a little conversion rate. I'll show you how to work with that at the end. Well, let's talk about the volume formula of cone. Look it up. What is it? That's right. 1/3 pi r squared times the height. Now we have the radius. We don't have the height. That's going to be solved for. Let me show you how to do that. You can draw a cone if it helps. That's the height. The radius is going to be 4. That length is actually here. That's your 15 centimeters. So we need Pythagorean theorem, guys, to figure out the height. 15 is the hypotenuse. So that's going to be your c squared. So take a second, pause it if you'd like. I'd like you to try to solve this out yourself. All right, hopefully you've attempted it. Let's just double check our work. This is 16. 15 squared is 225. We want to subtract that. So if you take away 16, you're going to get, oh, what is that? 209. So the height's the square root of 209, and that's where I'm going to definitely use my calculator there. So it's about 14.4568, so 14.46. All right, let's plug that into our formula. So my volume is pi, 1/3 pi r squared times 14.46. And I'm not going to do this in terms of pi because I already got decimals, so I might as well just get the decimal answer. So 1/3 pi times 4 squared times 14.46. It gives you about 242.28. And that's going to be cubic centimeters. But we want it in liters. So since there is 1 liter in 1,000 cubic centimeters, we want to know how many liters are in 242.28 cubic centimeters. So to do that, you're actually going to divide, because if you cross multiply and times it by 1 and then divide by 1,000, your volume is going to be that liters. So move the decimal 3 spots to divide by 1,000 or use your calculator. It's going to be 0.242 liters. And that's your volume. All right. Moving on to the next example. Excuse me. All right, example 3. A company makes candles in the shape of cones. Again, another cone. Their best-selling candle has a height of 4, h equals 4, circumference of 15, and we want to know the volume. So we need the radius. Remember the volume formula, 1/3 pi r squared times the height. But I have the height, I have the circumference, I got to get the radius. So circumference is pi d, or 2 pi r. If you'd rather do it in terms of r, that's fine. So 15, we're going to plug that in for c. 2 pi times r. So my first step is to divide by 2, or you can divide by pi first. It doesn't really matter. Just don't do them together. Just do one at a time. 7.5 is going to be pi times the radius. And then one more step to divide, and you're going to get we'll say 2.387. There's your radius. So we're set, guys. We got our height, we got our radius. We're going to plug in. So plug it into your calculator, pause the video, see what you get, and then unpause it and watch me do it. You ready? All right, so 1/3 pi times 2.387 squared times 4. 23.8667, so we will say 0.87. 0.87 what? What are the units? Well, we start with inches, so it's going to be in cubic inches. Inches cubed. There you go. All right, 2 more examples. Number 4. Find the volume in liters. So it's again one of those liters questions for an ice cream cone with a height of 7, diameter is 4. We need the radius. That's an easy cut it in half. So the radius is 2. And we'll use our cone again. popular figure here, pi r squared times height. So we're going to do 1/3 pi 2 squared times 7. And we'll put it all in our TI-84. 1/3 pi times 2 squared, which we should know is 4. So 29.32. And that's in centimeters cubed. Like the question before, a couple questions ago, we wanted to convert that to liters. So once again, we are going to divide that by 1,000 to get that centimeters cubed per liter. So that'll cancel out the centimeters cubed. That'll just get us the liters. And that's going to move the decimal 3 spots over. So 0.2932 liters. Okay, L for liters. That's your volume. All right, our last example. All right, example number 5. Find the base side lengths of a square pyramid that has the height of 6 and a volume of 22.92 cubic inches. So we're given the volume. We're given the height. Look up the formula. What is it? 1/3 area of the base times the height. So we first have to figure out what the area of the base is. So we're going to substitute V and H in for these two. And my recommendation would be to times 1/3 and 6 first. 1/3 of 6 is 2. You could multiply them together. It's 6 divided by 3. And you can rearrange these. So you can do 1/3 times 6 times B. It doesn't matter what order you multiply things in. So that's really just 22.92 equals 2B. So to solve that for B, we would divide by 2. And that's going to give you 11 point, what is that? 11.46. All right, so the question says not the area of the base side lengths. And it's a square pyramid. So the base is a square. So let's think about that. We got a square. What's true about all sides of a square? They're congruent. So if I'm trying to find that side length, I know that they're the same. And if I know that the area is 11.46, length times width, x times x is 11.46, that's a square. So square root that and you'll get the side of the one side of the square. So that's going to give you about 3 point something. About 3.385. So one side is going to equal 3.385 or 3.39 if you want to go 2 spots out. And the units are going to be inches. Remember, side is a linear length, so it's just inches. And that'll do it. Hopefully this is enough information to help you solve the volume formula questions on your day 5 assignment. So good luck and ask me if you have any questions. Thank you.